Alright, so today we're going to finish our look at Java. I know it's a high-paced boot camp of Java. And then we're going to do probably Tic-Tac-Toe and app lifecycle, perhaps. We'll take a look in a couple things. If we don't get through Tic-Tac-Toe, we can get halfway through it. It's all about Java. It has nothing to do with real Android, but it'll be done on an Android device. When you walk away, you'll have a Tic-Tac-Toe game, which is kind of fun. You can play Tic-Tac-Toe for the rest of the afternoon if you'd like. All right, so today's examples, for those of you who were having problems a few minutes ago, go into Android phone application development, go into supplemental notes, go all the way down to the bottom. We want Bootcamp 2. So instead of writing this like I did last week, I have like twice as many already put together for you, so it's a little faster. If you click on here, it'll say bootcamp2.zip. Go ahead and save it to your local system. And then you can close the web browser. You don't need that anymore. If you double click on it or unzip it using your programming utility of some sort that you have on your computer, open up Eclipse. Oops, opening up the trash. Opening up Eclipse, and I can see I have last week, so I'm going to leave that one alone. Close the project so you don't get confused with what's in it. We'll just leave that one alone. Go up to File and go into Import here, Import. And we're going to import an existing project into Workspace. And it's a general project. It's not an Android project, so don't select this one. This one says existing Android code into Workspace. It's not Android code, it's Java code. Just like Bootcamp 1 was Java code. So make sure you're up here at the top on the general. And then click on Next, and then browse for the folder. This is how you're going to use all of the time when you try to import projects. And browse to the desktop was where I put it. The folder is called Java Programming. If I click on it, I see all I have to do is click on Java Programming and then click on Open. You don't have to go in further. Just click the outer directory. Click on Open. You'll see it show up in the screen here. So mine showed up on the screen. The other thing I did this weekend was actually increase the fonts on here. So I'm trying to make it a little bit better for you to read. So the fonts are a little bit bigger. I might go a little bit bigger though. They seem kind of small from this perspective. So anyway, my fonts are getting bigger and bigger. Anyway, so let's see. So it's selected here, Java Programming. Go ahead and click on Finish, and you'll have a directory that's opened up. And so the illustration for today is broken out. If I open it up, and I open up as the SRS directory, I have 1, 2, 3, 4, 5, 6, 7 different packages. So I did this on purpose to show you the different package separation. They're all in the same project and everything could work together, but they're separated out into these different packages. So as an example, if I click on the source and I go up to File and I go New and I select Package, I can create another package. And I'm going to create this one another package because I'm probably just going to delete it. Another package. And then if I click on Finish, I see I have yet another package. If I take something, let's say from Abstract, if you open up Abstract, you see there's point and there's shape in here. I could, as an example, take, and this is in Package Abstraction. As an example, I'm going to drag it into another package by taking it here and just dragging it and dropping it into another package. And it's going to tell me to update the preferences, the references, and in shape.java, and I'm going to say OK, update it. Or you could update the qualifying name. I'm just going to select the first one to update the references. If I do that, now I have well, this is missing shape because I put it into here. Now if I look at package over here, it says package another, I misspelled package, but another package, whatever it's called, that I put over here. So this is what the update was. It changed the package name. Now I'm going to move it back because I don't really want it over here, so I'm just going to select and put it back over here into Abstraction. And it's going to say update the reference. Sure, why not? Update the reference. So now I've moved it back, and it said it found a potential match. Please change the whatever. Just go ahead and click on continue. Yeah, there was a potential match because it was back. It was originally there, now it's over here, now it's back. Long story short, I can now, if I want to just delete this package, if I delete the package and it has stuff in it, I'm going to delete it from the workspace. Or, excuse me, I can delete it. There's nothing in here, so there's no warning. You can delete it from the workspace, or you could just delete it from the project. Why do you want to do this? Because it keeps track of everything. So as an example, I have these one project that you downloaded and you imported. And in the project under abstraction, I have these 2 files. And then in the basic, I have a bunch of these files over here. And then in constructors, I have these guys here. So naturally, I organize this by what these things are demonstrating. So, all right, so let's start with the top one, abstraction. So I wanted to show you abstract classes and interfaces today, which is what I kind of left off on last week. If you refresh your memory, we did classes and we did inheriting classes from a class. We made instances of classes and stuff like that. And the more you get with practice, the more you'll get familiar with these different techniques. We have 2 other very important concepts. One's the abstract class, and then the other one is the interface. So I want to show you those. They're not very much different, except for the word abstract. So what I did here was I created 2 classes. We have shape and we have point. Shape is a generic kind of concept of a point or of a rectangle or a square. We have different types of shapes. So shape could be a base class that can just be, I could just say public class shape. And if I did that, I can't have this thing down here. This is an abstract class. So abstract classes are abstract because they contain at least one abstract method. So the reason why we had to make this class abstract instead of doing this, so this will work actually. I can put public class shape. And I can go, well, all right, well that works. But then if I want to add an abstract method to that public class, and the abstract method I'm adding in here, I'm going to talk about abstract in a few minutes here, is area. If I hover my mouse over this little red thing over here, it's going to say the abstract method area in type shape can only be defined in an abstract class. So if you have at least one abstract method, if you put an abstract method in a class, any class, all of a sudden the class turns into an abstract class. And the class is required to be an abstract class. So now I have to come up here and take this public. In fact, if I did that, I could do public abstract. Abstract if I spell it correctly. So now I got public, or I can just have abstract class. I could take out public, which I didn't have originally. And your example's not going to have it in there. So I'll just take it out. Public, by default, it's public anyway. So it's a good practice to put the public in, but you don't necessarily have to. What's abstract? This is a method prototype. Same thing that we see here in other languages. It's not implemented. It's not implemented because we don't know what the area of a shape is. We know what the area of a square is and a rectangle and stuff like that. There's different formulas for all the different areas, but we want each one of these shapes to have an area method to return the area. So if I want to have that as a requirement for all my shapes that are going to be inherited from shape, then, or derived from shape, depending upon how you want to view it, then I can put this in and I can make it abstract. Right now it says abstract public double area. It doesn't have to return a double. It could return a float. It could return an integer. I can override and overload this in my derived classes. But I don't want to implement it, because if I implement it and then I accidentally run this without redefining it or implementing it later on in my hierarchical classes up where the hierarchy, I might get the wrong area. Might be wrong. But I want to delay the implementation. If I want to delay the implementation, then I make it abstract. Abstract doesn't exist. Abstract is abstract. It's vague. It's void any implementation. So now I have an abstract class. This same rule actually applies towards C++ as well. You've worked with you can go pure virtual, which is purely abstract in C++. We don't have pure. We don't have virtual. We don't have to use the keyword virtual at all. We just use the keyword abstract instead. So this is equivalent to virtual if you're familiar with C++. If you're not, don't worry about it. But the thing with C++ is everything is a class, and everything can be inherited from one class. So you can do multiple classes. Here, because this guy is abstract, I can still only inherit one class from another class, which means I have to implement area in whatever I inherit from this class. And if I don't, I have to make that class abstract. So I can have abstract class, abstract class, abstract class, abstract class. Okay, not regular class. And I can only make an instance of the regular class. You can't make an instance of an abstract class. It doesn't work. Same rule you have in C++, it won't work. Because part of the implementation is gone. It's not complete yet. So we have a lot of different trains of thoughts on this. A lot of people don't like abstract classes in Java because you can only implement one class from another class. It's a straight line, single line inheritance. So they'll turn this into an interface, and I have interfaces right here, which is going to be our next example that I'm going to look at. And this one's called interface shape and interface point. It's the same example. So what I'm going to do right now is kind of run through the rest of this example. This is the abstract version of it. And then I'll switch it around and I'll show you the interface version of it. So here's shape.java. If I double click on interface.java, I see now that it's called an interface instead of an abstract class. So over here in shape, I have abstract class shape. Over here in interface, it says interface. Interface shape. I could have called it shape if I wanted to, actually, because I put it into a different directory. But anyways, just to remind me that this is the interface version. In the interface, I don't have any implementations. You're not allowed to put any implementations in here. So the difference between the interface and the abstract class can be partly implemented. In fact, it usually is. Everything's implemented, has data members, has member functions, except for it's got a couple of abstract methods in there that aren't implemented. So if I'm going to have a partial, I'll make it abstract. If I'm not going to have any partial at all because it's not allowed, all I want are abstract methods, then I have an interface, but they're not abstract. It's an interface. So it's like the .h file of C++, but we don't have a .h file. In Java, we have interface files. But here's the trick. We can implement as many interfaces as we'd like. We can only extend one abstract class, but we can implement multiple interfaces. So people switch the abstract classes into interfaces so you can put a lot more of them in there if you want. So if you know you're going to have more than one, you want to create multiple line inheritance in a single line fashion. You have class A extends class B, implements D, E, F, G, H, I, all through the alphabet, as many interfaces as you want, and then voila, you've got multiple interfaces and multiple classes all mixed up into the inheritance of one class that you've derived out of the whole shebang, which is how you get beyond multiple interfaces. So you have some textbooks that say never do an abstract class, always put it in an interface. And then you have some textbooks that say the exact opposite. There's like very much controversy in terms of the design philosophy. I will tell you most of the Android projects you're going to get are going to use interfaces all over the place. And then all your hierarchy for your abstract, everything, all of your special widgets and things that you'll be implementing will all come from abstract classes. Because it's all abstract all the way up to a certain point, and then the user's got to put in your stuff. Did you want to put images in the list box? Or did you want to put text in the list box? Or it's all the delayed decisions in terms of the GUI, delayed decisions in terms of the implementation. So a lot of Android people don't realize that you can actually do an interface until they see this interface come up and they go, what in the world is this interface? Not a Java programming course, but you got to be familiar with this because we're going to see interfaces. So, and we're going to look at abstract classes with Tic-Tac-Toe as well. So, anyway, long story short, what we have in here are just two methods. We have an area and we have a volume. And if we look at the shape abstract version of this, I just have the area. I don't have a volume in here. But I also have this data member here. And this data member here becomes part of the instance of the object that gets created from any, remember instances of objects that get created. They have instance variables, they have member functions, and they all come from the hierarchy. So if I make point derived from shape, point will have a color in it. We'll have everything. And you come over here to the interface, you notice there's no variables. There's no data members, I should say, in here. So all you put are methods in interfaces. So interfaces are a little bit more restricted than abstract classes. You just put the methods in there. If you put data members in there, you put variables, they become class level variables, not instance level. I haven't talked about static or instance, but we'll see that in a few minutes. But long story short, what we're looking at is a limited, it's not fully compatible. It's a totally different concept than an abstract class, but it's simply made for implementation, for standard, for protocols, for tagging. A lot of different reasons for looking at them. You'll notice that when you start using them. So let me finish this, let's say no for interface shape. I'm going to change interface shape. So let me go back up to the abstract method here. So point is also in the package abstraction. So we know that these guys are together, they're visible, they're public together because they're in the same package. And public class point extends shape. There's our inheritance. And then we have a static. And the static is an integer x and an integer y. You can just go and go, what's this keyword static? Well, that's going to be class level. So it's not shared by all, it's shared by all instances. So each new point, it's going to have an x or a y, but the point is going to be part of the class belonging. What does that mean? In order to use it down here, we had to make it static. This is a makeshift example because there's no driver program. Instead, what we have is a main static void main that's running in here. That's just a class level main function. That's going to be our driver program. So we're not making an instance of an object, but we are inside of main. So this is probably, and I wanted to show you this because a lot of the examples you find on the internet aren't broken out like they're supposed to be broken out. They'll stuff a main inside of one of the classes. So this is, I personally don't like this because this isn't standard, but you'll see this all the time. So I thought I'd mix this up, and there's a couple of different things in here I'll show you as well that's kind of weird. But we have static integer x and y. It's inside a point, and we got point here. This is a constructor. We're going to review through these examples as well, what we looked at last time. It's a constructor. This is the default constructor because it takes on, doesn't take on any, does not take on any parameters. And here's our double area. So public class point extended shape, shape head area. If I comment out this little area function here, and I come up to the top, I took out area, I come up to the top and I hover my mouse over here, it's going to tell me that the type point must implement the inherited abstract method shape.area. Bummer. Which means I'm required to implement that abstract method. I can't leave the abstract method. The only way I can get around that is to make point abstract. So people who are paying attention to, people who like look at this stuff and go, oh, I don't know what that means. I'll just do this one here. Great, but I still can't make, and I come down here and it's going to tell me that you can't instantiate a type point because point is abstract. Unfortunately, this is a lightweight version of what you're going to get in the future because you're going to be like, how come I can't make an instance of that? How come that's not working? Why do I have to implement that? And so we'll see it when we start making new Android projects. We'll come up here and we'll see public class, or here, I'll just go here, class point. I hover my mouse over, and what's going to end up happening is I'm going to add this unimplemented method, and then down on the bottom, I'm going to fill in the unimplemented method. So I like to use that kind of like a way of template, because then I know what's unimplemented, and it's usually the onClick, or it's the some method in there that you're supposed to implement to get your widget to do what it's supposed to do, or to get the interface to look correctly, because it's not implemented yet, because it did everything for you. You use the object that the SDK created for you. It did everything for you, but it's not complete yet. You got to do that last little piece in order to make it complete. So they make it abstract. So a ton of abstract classes. You inherit them the same way. I'm going to get rid of this override one. And this is overridden, by the way, because you're overriding it. And I'll put this back. And all we did in this main program that we have down here, and this is, I'm gonna kind of skip through this method implementation because we've seen this actually. We saw it last week. watch the video from last week. All I did here was I put a public static main method in here, and I made a point p is equal to new point, and point.print. And point.print is just going to print out my point, my x and y from my point. And so if I run it here, I'm just going to click on the point and do a run as, and I see it says Java application. If I come over here and I go to the shape and do a run as, I see run configurations. No Java application. Tells you right there you can't run that. Because it's, well, not only is it an abstract class, but not going to work for you. So if I come back up here to point and do a run as, what I'm supposed to get at the bottom, it's going to say select the resources to save it. I haven't saved any of these guys yet, so I'm going to say save yes. And then errors exist. Okay, that's fine. Proceed anyway. Here we go. The errors are down here, the interface. So we'll leave that error alone. Well, actually, maybe I should explain what just happened. I have a couple packages you've seen. I actually have several packages, all part of the same program. I have an error way down here in this package down here. I don't know what the error is yet because I haven't looked at it. But when I ran part of the sub package, it told me about the error. But look, it still ran. I have 0.0, the program actually ran because there wasn't a problem with that file. So here's what happened. You have pieces of partly implemented code, you have stuff you dragged in, you have part of the problem. I don't know what I did over there, but maybe I didn't save something. Who knows what happened there? But it ran, but then it didn't run, and it gave me an error. So what ends up happening is, unfortunately, that's Eclipse. So I got to go back over here if I want to, and this is good timing because I ran this. This one is just going to print out point from here. The point was 0, 0 because I didn't really assign a value for point because I got 0.00. So if I change point, make it 50 and 10, and I rerun it, I'm going to see that I've changed this resource. Would you like to save it? I'm going to say yes. It didn't give me the error that time. But now I see my outputs change. So I know this is working, I know this is changing, but I'm seeing these errors. So just FYI, it may not necessarily be with something you're doing. It might be something that you have saved in the project. So then you have to clean the project up. So I'm going to go over to the interfaces and take a look at this here. I have the package for the interface, and the interface is interface shape is the name of my interface. And I have my two methods here. And if I go up to interface points, now it says something interesting up here. It says import abstract.point. Because Eclipse was thinking too much for me. And most people would want to think, well, I know C or C++ actually, and I know I have to include, if I have a .h and a .c++, I got to include this one into that one. That's what Eclipse did for us here, which is wrong. We don't have to import. I don't have to import this point that's up here with this point that's down here. I don't have to do that. It's completely bogus. It completely showed up from nowhere. And again, try to explain why it showed up. I can't tell you why that happened. All I can tell you is it happens all the time. And if I didn't put it there, and I know I didn't put that there, I can just delete it. If I delete it and I can save it, it's going to work just fine now because it doesn't need to be there. Whoops, it still has a problem. Let's save this one too. What is your problem? Point. Oh, because this one's not called interface point. So this one here is interface point. Because I used, that's why it showed up. I made an instance of point, but I called the file interface point. It can't find interface point, so it went all the way up to abstraction and tried to import abstraction.points. So if I change this is why, well, logically it was correct. It found points somewhere in my project. It tried to include it in the same package by going abstract.point to import it in. But that's not the point I wanted to make an instance of. I want to make an instance of interface point. It's the same example. So if I do here and go interface point and say new interface point, now if I save it, the error should go away, which it does. And now I can run it. So yet another interesting, typo, basically, because I renamed this one interface point. I forgot to change it in the main. It found a point. that's why now I know why that import was up there, because it found a point in the project and it felt that maybe I meant that point. So it tries to think for you, and it tries to put stuff in there. And when in doubt, if you didn't put it in, take it out. You got a typo, which is I had a typo. So now if I run it, I'm going to run interface point. If I run it as a Java application, I see the same results as I did before because it's really the same program. This one's just called interface point. It uses an interface instead of an abstract class. So if you missed that, I had a typo. In my main, I was still making a point because I recycled the same example. So you put interface point instead of point in there because I called it interface point. I'm making an instance of this one. If I wanted to keep it as point, I could keep it as point. And if I did that, I got a couple choices. My first choice would be to copy this one, actually. To do a copy. And then to come down here to interfaces and then do a paste. And then say that some of the modified resources have not been saved. That's fine. Now I got point in here. And then if I double click on point, I see I got this little red thing. Because point extends shape, but I don't have shape. So I'd have to change this one and make it into interface shape. And then it's going to go, well, interface shape is not an class, it's an interface. Yeah, so I'd have to change this one and say, well, how about point implements? Because now I changed it from an interface, and then I go, well, class point. Then I'm going to hover my mouse over and say, well, add unimplemented methods. Because remember I had unimplemented methods in there. So I'm going to say, okay, add the unimplemented methods. And then finally I'm going to get this volume down here. Because interface had volume and area, had two different methods. My abstract class only had area in there. But who knows? I mean, I got a blank one down here. So now let's see if it works. If I save it and get rid of all the red stuff there and go ahead and run points. Now I'm running it and I got 50, 10 because I changed my original point to that. So now I'm using my interface shape. I mixed and matched, but I moved it into here instead of getting it. So my recommendation, move the file, make a copy of it to the local, because then you can change. If you have multiple packages, then you have that for a reason. So you can have multiple versions of the same. Like I have point here and I have point here. They're both in the same project, but they're in different packages. So that's the different package level. So think of it like a directory level. I'd make a copy of it, move it in there, change it around. That way you don't mess with the original or link to the original. Because inevitably, I might get rid of the original, and then half my project down here in this package isn't going to work because I got rid of it. Anyway, it's just a slight little tidbit there just to keep track of. But all right, so now I've covered abstract versus interfaces. So let me show you what else is in here. This is the abstract package and the interface package. I want to come up to this one. It says instance of. So before I made a couple of items, and I think we made person and employee, and I said I could have employee reference a person or person reference as an employee and typecast it back and forth and change it. I can tell from an object if it's an instance of another object by running a method call on it called instance of that tests to see what the object is. So object has a couple of useful, an object, we're all inherited from object in Java. Object has to print, has to string, actually I'm sorry, to string, it has a print method, but let's forget about that right now. To string, instance of, has a bunch of different built-in functionality that we can do on all objects. So this is an object, comes from object, it's a method we can run. So I'm going to show you, this is really a bad example. If I were to take this out of Eclipse and compile it, I'd end up with 1, 2, 3, 4, 5 different files instead of just one. But it's just showing it, you can do it this way. So I have class vehicle2, it could have just been vehicle, has a string name, And this is kind of another review and a kind of iteration of the same concept of a class. And then we have vehicle 2 is the constructor, and it sets the name to vehicle. And then I have class heavy vehicle that extends vehicle 2. We'll refresh our inheritance here. And then heavy vehicle sets the name to heavy vehicle. And then now I have class truck that extends heavy vehicle, and the name is set to truck. And then I have lightweight or light vehicle that extends vehicle 2. So that's kind of like heavy vehicle that extended vehicle 2. And it's going to set it to lightweight. So now I have a public class instance of. An instance of is defined here. Oops, let me just do it this way here. Separate file. Instance of is running instance of. You don't have to create a class like this. You don't have to do it this way. This is the driver program. I called it instance of because I called this instance of .java. It's the name of the class. It's not the method that we're running. This is the method that we're running. So in here, I've got, and I'm using static again because I'm using main inside of this. You don't have to use, if you have a separate file, you're going to put your main out over into a driver program. You don't have to use static like that. So, but you'll see this done a lot as well, same way. So anyway, I have a Boolean result, and I'll come back to, I'll revisit static in a few more lectures down the road. We have a heavy vehicle HV, which is equal to a new vehicle. We have a truck T, which is equal to a truck, new truck, and a heavy vehicle H2 that's equal to null. It's just going to be a reference. So here's our main, and the result's going to be equal to, it's going to come back true or false, is HV, he's a heavy vehicle, an instance of heavy vehicle. Well, that's going to come out true, because it's an instance. And then we have result T for the truck, result T here, truck, instance of heavy vehicle. Well, okay, so T is a truck, and truck extends heavy vehicle, so that's also true. So that's going to come out true. They're all heavy vehicles if they're extended from heavy vehicle. That one's going to be true. And then we have HV, heavy vehicle. Heavy vehicle, is that an instance of truck? Well, let's see, heavy vehicles here. Is he an instance of truck? Well, it's going backwards in the hierarchy. So we'll see how that one turns out. In fact, let me just run it so we can see. We run it, we see a bunch of trues and false. Alright. So the third one is false, by the way. Heavy vehicle isn't a truck because it's going backwards. So heavy vehicle is here. Truck is a heavy vehicle, but heavy vehicle isn't a truck. So heavy vehicle is a truck, false. And then heavy vehicle 2 is a heavy truck. Well, heavy vehicle 2 here is an instance of heavy vehicle. Well, that one's heavy vehicle. Wait a minute. H2 is null. It's null, so it's not. It's not because it's null. Although you did it with heavy vehicle as the reference type, we didn't assign it. We didn't do new heavy vehicle. We made it null, so it's not a reference of it. What this example is supposed to be doing is showing you the hierarchy. So everything, you're a part of everything above in the hierarchy. You're not a part of everything below. So if I'm a truck, I can't be a vehicle. I am a vehicle. I can't be a, I'm a vehicle. A heavy vehicle is a truck, but a truck is not a heavy vehicle because it's going the opposite direction. So imagine your current state as an object, up to object. You're a member of all those classes, which means if you are, you can be referenced as all those classes. So I can be a heavy vehicle and somebody can reference me as a truck. I'm still a heavy vehicle, but I'm also an instance of truck. I have one inside of me, so I can be a truck. So you'll see a lot of object casting for like kinds. So if I have a bunch of list items, I did an internet results search and I have numbers and I have characters and I have a bunch of stuff, but they're all in part of my results set. I cast them all as my results set. I stick them all into an array. I stick them all into an element. I use them all the same, but they're all different. All the different URLs are in there, all the different numbers and strings and stuff. common for getting like kinds together, getting them all together. And we can find out what they are by using instance of. So instance of is that example there. I'm kind of going to go through these pretty fast, so let me know if you have questions as I go through this. All right, so that's instance of. The more interface, if you're interested in looking at this, and I'll just show you what's here. I actually broke this out with a test. So we have test.java. Test.java creates. This one is a little bit, the more interface is a little bit more advanced than what we need to know. If this were a Java programming course, I'd be going through this in a lot more detail. But if you're interested in seeing how to, and this one's broken out properly, there's an array of objects put together so that we create circles, cylinders, points, and shapes, and we put them into an array that's a type shape. So the way that we get, especially with this is interface classes, excuse me. The shape interface makes it a shape. So they're all instances of shapes. So we can make instances of circles, cylinders, everything, points, put them all into a shape array because they're all the like kinds. Because you can only put one element type in an array. So you make an array of shapes and you put circles and cylinders and all that other stuff inside of it. And it all works because they're all instances of that. So here's our interface here. The interface is shape, and then inside a circle, it extends point. Point is a, here's point. Class point extends object, implements shape. So it implements shape. So we used the interface in the base object point. We took point, we put it inside a circle, and people are wondering, well, where'd the interface go? It's in there. It made it in on the first round of the hierarchy. So we have another breed of people that constantly implement this interface, implement the interface. That's extra. You don't have to keep writing, and each, like circle doesn't have to extend point and implement the interface because point implemented the interface. Unless you want to implement the interface again, and then you can implement the interface as many times as you want. So what ends up happening is by the time you get to this class, maybe it won't even be abstract, maybe it'll just be a class. And then when you implement it or you extend it, it'll have all this other stuff in there as well. So it's very feature-rich at one point. Anyway, that one's kind of above and beyond the scope of this course, but it's, if you take Java programming, we'll get into different types of using multiple interfaces, using multiple classes in a hierarchy. So, all right, so let's move on to the rest of this here. Interfaces, instance of inheritance. If you had a problem with last week's boot camp and you want more information on inheritance, go ahead and look at this one. And in this one here, we have class box, and then we inherit match box from box. So match box extends box, and then we just added some more information to it, and then we just created an instance of match box here. So this one here called inheritance is extremely easy. It's a stripped down version made to give you yet another example of inheritance. If you had problems with constructors, obviously you want to go to this one here. It says constructors on it, and we have constructor chaining. Well, the basic one here is just called constructors. It is a bunch of overloaded constructors. In fact, in the class constructors here, it's got a length, a height, whatever, some variables that are declared, and we're just setting these values, not really doing anything with it. And the one that's called overloaded constructors, we are creating multiple constructors taking on different numbers and different types of parameters. And we're just changing the orders around. The more interesting one here is the constructor chaining. So in the constructor chaining, we have cube3 is the name of the class. And then in cube3 we have a method called getVolume. And then we have constructor chaining going on. So this constructor here, cube3, sends this 10 and 5, 10 and 10. So last time we looked at super. It sent super, which is the object above it in the hierarchy, And it sent it, if I were to send super 10 and 10, in my base class that I inherited from, there would be a constructor that took on 2 integers. Here, this is chaining one constructor to another constructor. So instead of cutting and pasting all the constructor code and sticking it inside of each one of these constructors, you can chain them together with this. So this says call the instructor and give it 10, 10. Well, here's one here that says 10, 10. Well, here's one here, excuse me, integer I and L and integer B. Here's where my 10, 10's going. And then this one here, this one's going to send it 1, 2, 3. Well, here it is here, 1, 2, 3. So this constructor calls this constructor calls this constructor. Little bit better than cutting and pasting all the code and sticking it inside of all the different constructors. This works actually. You can go this dot something, this dot something. You can say this, send it parameters, and you're sending yourself stuff. If you say super, you're sending the object above you. So just keep that in mind. You'll see that in a couple of examples. What I'm trying to do is show you the common stuff you're going to see in Android. Obviously not a replacement for a full Java programming course. All right, so save that one. The last but not least, the directory you're going to find probably the most helpful is this one. It's called Basics. Basics go in through Java Programming 101. We have one here that's called Access Modifiers. If you look at this, it's going to be about public, private, protected. It's using public, private, protected. Those are called the access modifiers. Gives you an examples about how to use those access modifiers. Again, I'm not going to go through it. Counter keeps track of a increment counter, item increment, which is going to return an item. It returns this item. So we're the list. We have the items inside of us. We're item. We have integer I. We have a return type of item that's going to, there's an increment method. It's going to go I++ as a counter, and we're returning this, which means we're returning ourselves to ourself, which is kind of the interesting thing. And then we have void print, and then down here we have new item, and then we have, this is the interesting part, x.increment.increment.increment. So we can chain multiple method calls within the same. So you can't, I don't know, can you do that in C++? I don't know if you can do that in C++. In Java, you can run multiple method calls together all in one shot. You can go dot this, dot this, dot this, dot this, dot this. And you're chaining together 1, 2, 3 increment calls with a break call. You'll see that not so common. People don't like that. I don't know why people don't like that. You won't see that very much. But anyway, that's what this one's showing along with returning this. So that's counter. I'm not going to go through them all. If you have problems with basic syntax, yeah?
So when you chain them together, does it read left to right or right to left? Does it print that increment 3 times?
Oh, it reads left to right. So it goes in the order that you're giving it. So if it's increment 1, we'll go to increment 2, increment 3, increment 4. But the funny thing is it could be increment, print me, do this, do that, all to this object. It's like, wow. Because a lot of times you'll just have main, and main will just run a series of method calls to do something to the object. Because that's how you're going to automate the behavior of the object. You're just going to have it do a bunch of stuff. So you just run the methods, just string them all together if you wanted to. People don't like that for some reason. You hardly ever see that. So anyway, if else, if statements, logical operators. Logical operators are the ands, the ors, the and the or. Math is actually kind of an interesting one here, where we're just going to use plus, minus, divide, stuff like that. Basic math skills. Overloading methods, the object class. It's going to look at element. Well, this is going to actually do something else too. It works with a vector, but working with data structures and stuff. So if you're interested, case switch, stuff like that. If you're interested in looking at some basic stuff, that directory will be good as well. So I kind of want to stop with the Java. Gave you enough to work with. And I want to talk about app building 101 at this point. And I want to talk about the app lifecycle. Then we're going to hit Tic-Tac-Toe. So we'll do something fun by the end. When we start hitting Tic-Tac-Toe, you'll go, oh, abstract class. Oh, interface. Oh, you know, and then all of a sudden you start seeing all these pieces, hopefully. So the life cycle. If you go into Android phone application development, oh, I think I have attendance, which is actually probably a good breaking point. So let's pause for attendance. Okay, we're back. So I want to take a look at the app lifecycle, and then we'll do tic-tac-toe. So we got plenty of time. So if you go into the bhacker.com, go into Android application developments, and then go into tutorials. We want the tutorials link this time. If you go into tutorials, I'll show you both of them. The one up on the top here is called Life Cycle Tutorial, and then we have a Life Cycle Solution. So download both of these too. This is the completed Android project. And then we have the tutorial for Tic-Tac-Toe. That's a PDF file. And then we have the Tic-Tac-Toe solution. Then we have Tic-Tac-Toe images. Those are your X's and your O's. We're going to use a Java. This is all done in Java, not in Android actually, but it's an Android project. But I'll show you that when we get to it. And then we have Tic-Tac-Toe Solution 2, which is another solution of the same thing, just done differently. Has a slightly different implementation to it. Because there's a couple of different variations of Tic-Tac-Toe. All right, so let's take a look at the life cycle. So if you open up the life cycle, there's a little bit of, so the tutorial is not very much to it, but what I want to show you are kind of the different phases of the app life cycle. And we have different types of things. As an example, the type of apps that we're working with right now are called activity apps. And activities, in general, are single, it's a single focused activity, a single thing that the user can do. And when the first Hello World that we looked at took one activity and switched it to another activity to another activity. There's a lot of Android developers who never get past activities, actually. It's probably the most common type of app. And in the activity, you have one screen that goes to another. So we have the main XML file, or the activity _ main XML file. That's attached to a Java file, to a Java class file that gets created. And then the application can run multiple different screens, multiple different activities can run, switching from one to another. And then the application runs in its own Linux process. So we have one Linux thread, Linux process / Unix process. Think of it like a thread if you can, or a process from well, you guys were taking the Unix class, it's a process. And we switch the activity that's running in the process back and forth. And the activity itself is the thing that has the life cycle to it. So we have activity states. It's kind of like process states. When processes are created, they're new, and then they're running, and then they're paused, and they're waiting. We have the same thing with the process of an Android app as well. The activity itself is nothing more than the abstraction of a process. But we don't actually have to create threads. It's done for us automatically. Here are the active states. We have active, running the activity in the foreground of the scene. That means the view is up there, the activity is running, and it's got full focus of the phone or the device that you're on. And then we have the paused. It lost its focus. You ended up clicking on the dialer or the contact list. You clicked on something else. It's out there, but it's paused. It's still visible. You can still get to it, but it's not currently running. Something else is running. And retains all its state information, and in extreme memory situations, it may be killed. It might be garbage collected as well. And then we have the stopped, where it's not visible anymore. It retains all of its information, and it often will be killed if we need to reclaim the memory. Now when it's killed, it's no longer part of the life cycle. It's dead. It's closed and it's exited. So to see this in action, we're going to run the following example. Instead of cutting and pasting and putting this into a project, we're just going to load the finished project, and you'll see it run. If I look at the source code for this, actually, let me just look at it in the completed project, because you all downloaded the completed project. Say that one more time.
Unable to download because probably everybody is trying to download it because it's getting really slow.
Are you serious? You can't download it? Nobody can download it?
No.
Are you serious?
It's so slow.
No, you're joking me. No, I'm serious. Why would you joke about something like that? How come I can download it? Well, let's see if I can download it or not. Solution. You're right. Well, it's not my website, it's the internet access here. I don't seem to be getting any response at all when I click on it. All right, let's just build it from scratch. Did you guys get the tutorial part?
Yeah.
We'll just work from the tutorial part. We'll build it manually.
Great.
All right, so open up a brand new Android project, Plan B. I'll just build it. It's no brainer. File, new Android application project. And I'm going to call this one Life Cycle. And I'm going to use, it doesn't really matter what I use. I'll just keep it on 2.2. That's fine. Or whatever it's on, it doesn't really matter. We're building it from scratch. Click on the Nexus until you get to the end, and then click on Finish.
Professor, I have a question.
Yes.
It says when we click next, it always says working set. Add the project to working sets. What does that mean?
Don't add it to another project.
Oh, okay.
Do you want to put it inside of something else, or do you want to keep it to a separate? I always like to keep things separated out. A lot of people like to put things together. See, now it finally opened up, opening a Lifecycle app. Doesn't really matter. Create a brand new Android project. See if you can download the Tic-Tac-Toe tutorial then as well if you get access. It's still not allowing you?
I will try it again. No, it's just.
Mine finally came up a few minutes ago.
Yeah, now this is okay.
Now it's what?
Yeah.
It's not opening the site.
Is the internet down? Can you go to other sites?
Now it's okay.
Now, now I'm able to do it.
Now it's working?
Yeah.
All right. The code that we're going to do here is part of main activity. Main activity, we're going to keep a couple of different states. And we're going to look at, if you look at the code here, actually, if you just look at the PowerPoint that's in front of you right now, I'll just go over it right here. And all you do is you cut and paste this and you stick it in the main activity. And we'll do that in a few minutes. So, public class main activity extends activity. We are making an activity object instance. Remember I said activities are probably the most popular type. It's one of the types. We're going to see more in the future. I have 3 different variables. I have paused, killed, and stopped. And these are going to be determining the 3 different states of paused, killed, and stopped. And they're all equal to 0 right now. And then I have a text view that's going to put something out on the screen for me. Remember what we did last week with the bootcamp thing? It's the same concept. There's this text box out there. We're going to write the text of, well, it's probably going to be the value of paused, killed, or stopped out there, actually. So we have our onCreate. That's our new. That's in the beginning. So we're going to use this thing called save instance state. Saved instance state is the information about the life cycle of the app that's being saved so that when the application gets paused, we can go back and we can get what was paused, what would happen, what was the current state of the app, what was loaded, what was not being used. All the information is being saved. So on the onCreate, we get this by default. We take in the saved instance state. If the app has never been run before, this is the first time we're running it, this is empty. If it's running, it's sitting out there in the background. We pause it, we bring it back up, we get the state information, it comes back in. So onCreate is really the method that's controlling all of the instance information and the bundle of the saved information that's associated with it. So we're going to run the super onCreate and send it the saved information state, because we need to restore our super object as well back to what it was initially. So if it's nil, which means if it's not null, blah, then we're going to say that the paused is going to be equal to, well, the saved instance state get integer from paused. So because paused up here is an integer value, the state is actually saved in integers. So we're going to say killed, it's going to be from killed, and these are going to be text fields, which is why we're getting an int from it. These are a text field that's going to be appearing on the screen. So we load the app up, Actually, I should just load the app up in a few minutes. Load it up. We got 1, 2, 3 boxes. We parse the text, we parse it into an integer, and we give it to paused, killed, and stopped. So we can keep track of how many times did we pause the application, how many times did we stop it, how many times has it been killed. Every time we build in, and what it really it's doing, it's getting it from the saved instance state and from the value of paused, killed, and stopped that are on the GUI. So it's really weird. We're actually taking the GUI from what we had in the past, reading it, and then calculating out what happened to it the last time when we were there. Yeah?
So during the process, in-app process, this on create can be called any number of times in the process?
Correct.
Okay.
It's on the create, which means on the load.
On
Why
the
they called it create, I don't know, because
Yeah.
on create gives you the impression that it only happens once. It happens every time you go to access the app. Well, the app might be minimized, it might be sleeping in the background. When you go get it again, and I'll show you this in the emulator in a few minutes, when I go to go get it again, I'm on creating again, but I'm creating it from a saved state, and I'm getting the saved state, which is what was on the GUI, what was the app doing, all the information that was being stored for the app. And then I'm incrementing these integer values to see how many times did I pause it, how many times did it get killed. So here we have the text that's going to be equal to the new text new text view. There's a text view. And we're going to set the text to pause, to stop, to killed, so that we can get that information. And then we're going to set the context view to text. And then we're going to go through the different things that happen. So on the resume, we're going to set the text to when we resume again, we're going to update the text. On the start, we're going to update the text. On the stop, we're going to increment the stop plus plus. On the pause plus plus. On destroy, killed plus plus. You want to keep track of what happens with these integers over and over again, or excuse me, with these things. And then we have this method that's a protected method. These are all protected methods, by the way, which means they're good between the different instances of the same object and the same hierarchy, which means super can access this stuff, but the public can't access it. So it's not private, it's protected. And then, because we're running super on resume, super on start, the requirement is at a bare minimum, we have this method, on create. We don't actually have to keep track of on resume, on start, on stop, on pause, on destroy, on kill, all the other stuff. But if we want to do some cleanup work, we have a bunch of files opened up, our app gets destroyed, it gets killed, we can go ahead and close all those files. It's equivalent to the destructor of an object in C++. We don't have a destructor in Java. We don't even have one in the Java language. Because we don't have that in the Java language and we have automatic garbage collection that comes around, if we want to do that manually in an Android app based on Java, we have all these weird methods they added to it. And all the weird methods are coming from this activity. All of these methods that are being overloaded are extended from activity. Activity has on create, on resume, on start, on stop, on destroy, all those other stuff. So here we're just basically running supers and then incrementing a counter. Yeah?
So all these methods will be a part of all the applications that are going to be built on
Correct.
Android?
Every single application you work with can use all of this stuff.
So
Because they all come from, if you're working with an activity, if you're extending activity, all these methods can be used. So what I'm going to do is I'm just going to cut and paste this because I had that project opened up. I'm just taking the onCreate and everything afterwards. And unfortunately, when you copy and you paste out of preview or PDF files, it sometimes messes up the formatting, but let's just see what happens. So if I click on the file that is running this in the source code directory, I have mainActivity.java. MainActivity.java, I have onCreate and onCreate options menu, which is the options menu that shows up when you press the options button on the particular device. Doesn't really matter if I have that. I'm actually just going to get rid of this here. And I have to remember that this is called main activity that extends activity. And I'm just going to paste this other code in here. And then I'm going to come back up to the top. This is main activity. It extends activity. And then I'm going to put the imports in. So import the text view, which I believe is the only import I'm going to need. And there's a quick way of fixing the formatting, and I can't remember where the button is, but it's in, I think it's Control-Shift-F. So Control-Shift and F. No, it didn't work for me. There's a menu option for it. Huh? Command-Shift-F on a Mac. So Command-Shift-F will fix the formatting for you. There's also a menu option for it as well, but I can't remember where the menu option is. But if you go through the menuing system, you'll find it. Because what ended up happening was from the PDF file or the text file. So, all right, I can get rid of this view up here. Don't really need it. But now, if I run the project, yes.
The saved instance state is basically having all the information about the query side.
If I have 3 integers in my app, the saved instance state is going to keep track of the values of all those 3 integers. It's also going to keep track of what I was doing. What did the user press? What is visible right now? Imagine it's a snapshot of what happened with the app. It's what's going on in the app. Because if I have a running program, I'm going to take the program out of memory, and then I'm going to put it back into memory. Because at any one moment, single moment of time, only one process is running. So if I have a process that's running and I want to stop the process, put it over here, run another process, I have to restore what happened in the previous process if I want to go back to it. The saved instance state is all the information I need to restore it. So, all right, so now, yeah?
On saved instance state, that packet.
Yeah, on the saved instance state, then take and create on the out state, put the value of this, you're adding it to the instance. So when you're saving the instance, put in there the value of these 3 integers. So when it reloads back up, it takes from the onCreate the saved instance state. So you can add to it, which is what this is doing. So you're adding to it the value of these 3 integers so that you can come back and pull these 3 integers out later on, which is what we're going to do. So if we run it, we see you can run as a, oops, let me run the project, excuse me. Run as an Android app, save everything here. I've got my emulator running in the background. I'm going to select the emulator. Okay, so those people who are still paying attention, I have the app running. It says pause 0, stopped 0, killed 0. So I'm going to click on this little guy over here. He's my button on the side of the phone. If I click on the button, oops, hold on, I have to integrate my mouse. Yep, now my mouse is integrated. Very good. If I click on the little button, I'm going to click on Home. I didn't kill the app. The app is still running. So I have the app running right now. If I clicked, well, you see already paused incremented to 1. I already paused it by clicking on the side menu bar. That would have changed my home screen anyway. It didn't change the emulator because it put it down here. So now I have paused on 1. I'm already paused, so I go home. If I come into the application area here and I go and I select it again, it's called Life Cycle. It's already installed on my emulator. It should be. It gets installed when you first run it. Here it is right here, I'm sorry. Life Cycle. If I run it again, now I have 2 paused because I paused it, then I paused it again when I ran it again. Now I have 1 stopped. Because the original one stopped because the second one got reloaded. So it was smart enough not to load 2 instances of the same app simultaneously. Now if I killed it, I don't know if I can kill it with an escape key. Let's just see. Nope, I killed it, but I killed it. I escaped out of it. The button on my emulator, the kill is the escape key. I can't record it because I killed it. So the logic of the kill counter isn't going to work. It's always going to be 0. Because if you kill it, there's no instance state left to save. how are you going to save it? It's killed. So that logic isn't going to work. But you can play around with it and you can see that eventually, you know, if I load it up a couple of different times, I got stopped one, paused one, killed one. I didn't put the destroy up there, but on the destroy.
The one, the last one? Or this one?
It's this one because I loaded it up. I went to the menu, I loaded it up again. It stopped the first one and regained the second one. It paused the first one, stopped it, and then opened up the second one. Because you can't have multiple instances of the same app running. It's going to stop the first one, load the second one. So play around with it. You can put different things. You can have like a toast message come up when you pause it. It says, hey, are you doing anything? Why are you leaving me? I'm up, I'm running. Why don't you just leave me alone? And then when you exit it, it can say, hey, you're closing me down. Do you want to save your work or something of the other things? So anyway, that was an attempt to show you the different life cycles, states of the app. Dwell on it, think about it. Let's do some tic-tac-toe, and you'll see how Java works with this as well. So I'm going to close this project down. Hopefully you guys have loaded up or gotten at least the PDF out of the tic-tac-toe. All right, let me load this one down here. But the, I don't know, life cycle one is pretty easy in terms of being able to figure out, being able to see it. All right, so this is what we're building. It's an Android tic-tac-toe game. So we're going to build this in pieces. It's actually 100% Java with an Android front end. We're not even going to be working with the XML interface. The next project we do will be 100% Android, no Java. So we're going to see both extremes here. So it kind of shows you how the Java fits in with the Android environment. So it describes how to use 2D graphics and the draw. There's a draw technique. You can do this with Swing, and you can do this with Java 2D. The same source code works both ways. Actually, have the source code if you're interested. You can use it with Swing. You can write a Java application that does the same thing, looks the same way, does everything the same way. So the underlying implementation. The basic description of the algorithm is going to be a step-by-step form. So we're going to create a tic-tac-toe project. We're going to add some images. So we're going to see how the directory for the drawable works with the X and the O. And then we're going to program the game logic. Then we're going to run the program. So the first thing we want to do is open up Eclipse, and using the project wizard, we're going to select an Android project, and we're going to create a new tic-tac-toe game. So this is older screenshots, but it should still be the same. So let's just open up Eclipse, and I'm going to get rid of this life cycle one in here. Just kind of a minimal. So I'm just going to clean up my palette here a little bit. Get rid of this one. Don't need Java programming either. I actually don't even need Boot Camp in here. I'll just leave Boot Camp. Anyway, so File, New, Android Application Project. And then I'm going to call this a Tic-Tac. I know, you can call it Tic-Tac-Toe. You can call it anything you want. Seriously. So, all right, here, right? I'll call it Tic-Tac-Toe. There we go. And go ahead and click Next. Go ahead and click Next again. Click all through everything and just click Finished. We're going to just use the defaults for everything. Close main activity. We're not going to use main activity. We are going to use main activity, but we're not going to use it this way. So, all right. So, and then it's also in the PDF file, so you can then download and look at the PDF file later on if you get stuck in any of these stages. Alright, so we have the source code file that we ended up with, and we had main-activity.java we get by default, along with main_activity.xml we get by default. That's the starter point. So now we're going to add another class. So I'm going to show you what we're going to do is build an Android/Java project. We're going to see them both working together. So we're going to click on the package, source code package, and we're going to add a new class to the package. And the new class that we're going to add to the package is going to be called Cell. Because we're going to create this thing, and we're going to create an abstract class called Cell. Cell's going to represent an X, and it's going to represent an O, and we're going to have 6 of these cells that are going to be printed on the screen. because of what I'm showing you is the object-oriented way of creating this using all these Java techniques. So let's create an abstract class called cell, and we'll stick it into our project. So go ahead and click on the source code directory. So automatically you're in layout. So I just close this down, or minimize it back up. Click on SRS up here on the top. Click on the package. Come on up here and go File, New, and we're going to create a class. And now we're going to click on this little button here that says Abstract on it. We are creating an abstract class. And the abstract class we're going to create is going to be called cell. So type in cell. You don't have to put the .java in there. And it's going to say the type name is discouraged by convention. Java type names usually start with an uppercase. Alright, so I can put in an uppercase cell if I want. There we go. Now I'm proper and I don't have any more error messages. Alright, so we have public selected and we have abstract selected. So go ahead and click on finished. And then you're going to look at your Java project. People are going to say, well, how come, what's this abstract class? Well, that's what we just went through. That's why I kind of wanted to show that to you. So we have cell. Cell is going to represent the concept of an X or a Y that's going to sit on our screen. So let's go back to our PowerPoint here, or PDF. PDF's got a lot more screenshots on it. Don't worry about it. I already kind of went through it. So cell. We want cell to extend point. So remember in the beginning of this lecture I had shape and then I had point. We also have point. We have a 2D graphic. So there's a Java 2D is actually the name of it. It's in the graphics package. And we have paint, we have point. Well, let's not worry about the imports right now. Instead, and it's also we have resource here. Instead, let's just change point to change cell to extend point. So if I do that in here, I go back up here, I just add where it says public abstract class cell extends point, capital P-O-I-N-T. And then I hover my mouse over the point and I say import point. Yes, I want to import this guy, so I click on yes to import him. So now I have import Android graphics point. Point is defined by an X and a Y. It's geometry. It's in the graphics package. We also have circle, we have square. All that stuff is included for us. We never have to actually write that stuff. So. All right, so now I have point. So now I'm going to figure out, well, what am I going to do with point? We're going to have a constructor. This is a constructor here. And the constructor here is going to take in an X and a Y to create our point coordinate system X and Y. So I could write it, I could type it, or I could just cut and paste it. So I'm going to try the cut and paste method, copy and paste method. So I'm just going to come over here. Inside of the opening and closing bracket for point, I'm going to add in here, paste in here, and I got public cell X, Y. And I'm sending super X and Y because who is super? Super is point. Point's defined by integer X and integer Y. So point is a point on the, okay, we don't have to know geometry. We just know you need to know on a 2D graphic point X, Y. You can go 3D and go X, Y, Z, but we're doing 2D. So we also have a 3D package. We also have OpenGL that works with this too. But we'll go back to, I don't know, high school geometry. X and Y. All right, so we got cell, so we can create a cell with X and Y, and we send it back to super. All right, so let me get back to my, here it is. There we go. Now we created an abstract class for a reason. We're going to have an abstract method. And the abstract method we're going to put in here is going to be called abstract void, public void draw. And public void draw is going to have three different four different, actually, we have canvas, resource, integer X, integer Y, integer W, and integer H. We're going to have a height and a width. We're going to have a point to start the drawing. We're going to have canvas and resource. Well, resource is going to be the x.png or the o.png that we're going to put in there. And then canvas is going to be the screen, the 2D canvas that we're going to stick this thing on. So we create a canvas. We find an XY coordinate on that canvas, which we're going to set. we start drawing the resource with a height and a width that we're going to give it. But we don't know if it's going to be an X, we don't know if it's going to be a Y, we don't know where we're going to stick it. We have 6 different coordinate systems, we have 6 different locations we're going to stick this thing in. So that's why we made it abstract. So we can call it 6 different times, put 6 different things out there. So I'm going to copy and paste this guy. Actually, I just have to take this guy here. He's a method prototype. And stick him in here underneath my constructor. So you know we just made a constructor. And now we're going to put in this abstract method here. The abstract method is going to tell me that I need to import canvas. So what I did is I put it in. You don't have to do it this way. You can put the imports in manually first. I like to do it this way because then I only import in what I need. So I'm going to hover my mouse over. I'm going to say, well, import the canvas and import the resource. Import resources from Android content resource. Now I should have a pretty good abstract base class. I can't make an instance of cell. Instead, I'm going to have an X. I'm going to have a O that I'm going to make an instance of. Lose anybody? All good. What we're doing is we're seeing Java programming applied. So, all right. So I'm going to save this guy here. So now I have my cell.java. I shouldn't have any error messages or anything at this point. Not receive any error messages or warnings. Change your package name if you have different packages, yada yada. We have 2 different things that end up on Tic-Tac-Toe. We got, this is going to be called circle, so I'll use the circle. You can change your name. If you change your name, just remember what you changed it to. What do we got? Circle and cross. I think this thing is going to use cross. Cross is the other one. I'm going to take the steps out of order because if we're going to have to create 2 new classes, might as well just do them one after the other. All right? So, and you know, circle and cross are both going to extend our base class cell. They're both types of cells. So we're going to create a new class. We're going to call it circle. This class is not abstract, but it will use cell abstract class in its implementation. So use the following settings. Let's take a look at the settings. Well, circle, public, superclass. Well, we can change the superclass to cell because we know that. So let's go ahead and make a couple of new classes. So I'm going to click on the project folder. I'm going to put my 2 new classes in here. I'm going to go File, New, Class. We're going to call this one a circle with a capital S. Circle, if I could spell a circle. Now on the superclass, I can put cell in here. I was going to say I can also browse to see what kind of one I do. But this is the superclass. If we don't put superclass in, and I'll make another one without this. I'll just put object in the next one. You'll see what I'm talking about. If I put cell down here as the superclass, we don't need a method. We don't need to public anything. Oops. We don't need to select anything down here. This is a bigger picture for you. But what I did is I took out object and I put cell in here because then it'll automate it for me. So in here, if I press on finish and I look at my circle, it's going to say extends cell. And I say, what are you complaining about? What are you complaining about here? Add constructor circle int. Okay, we'll put the constructor in here. And then it's going to say, add unimplemented methods. Okay, remember, cell is abstract, and we have an unimplemented method. So this is what I call program by error. All right, now what do I need? All right, add unimplemented method. Sure, because I know that I'm extending an abstract class. Now all my errors went away. My errors went away. So I put the errors in there so that I can take care of the errors. I won't get the errors if I do this. Watch this. So this is circle. I can save circle now. And all the errors and everything go away. And if I look at circle, I've got the circle that extends cell, and I've got the constructor. And my constructor already overloaded the super constructor because super is cell. Cell's taking on an x and a y because super is coming from point. Cell's coming from point. It has x and y. And then I have this override. This is where this at override comes into place too. At override, because I'm overriding the abstract method, and here's my implementation of it. So watch this. If I do it, don't do this. Just watch me for a second, but don't do this. If I come up here and go File, New Class, and I go, okay, this one's going to be cross. And I leave it on Java Lang, and I go Finish. Now I'm stuck here looking at this thing going, okay, where's all my cheat sheet help? I don't get any cheat sheet help out of that. So then you could take this approach here and go, okay, well, let's just extend cell. Extend cell. So if you did this, if you didn't do this, then I'm back where I was before. Extends. Now I'm back where I was before. So if I'm going to get there anyway, I might as well just replace Java Lang object with cell, and then I get there initially faster. I don't know. It's your choice. Do it any way you want. So now I'm going to go through, and now you guys do this one way or the other. We need to do this again for cross. So you just did it for circle. We're going to do the same thing. We're going to add the constructor. Then we're going to add the unimplemented method. This is the unimplemented method here. That's this abstract method down here. Notice it's not abstract anymore. Abstract methods don't have a method body. They just have a method prototype, which is it's the signature. It's just this line right here with a semicolon at the end. Same thing you get with a .h implementation interface file in C++. So. All right, so now I have a cross and I have a circle. I'm ready to go. I need some game logic, you know, so let's see what's going on here. So change the circle class to the following pre-written code. Well, didn't it do this for us? We did this already. We got that. But we don't have the implemented, we just have a blank implemented method that we're going to use for the onDraw. Excuse me, for the draw. It's not onDraw, it's draw. So we have to add this code here. So in the circle draw method that we're overloading from the abstract base class, we're going to put this in here. I'm going to copy and paste it, and I'll talk about what it is we're doing in a second here. And I'm going to go up to the circle. And what I'm doing is I'm pasting this into draw. And if I do that, I have this lovely thing here, and it's going to say to me, well, what's going on here? If I hover my mouse over, I want to put paint in here. So import paint. And circle here, don't do anything with this. So let me talk about what's going on here. I'm going to fix the bitmap. I'm going to import bitmap. I'm going to import bitmap factory. And I imported paint. And then over here with rec, I'm going to import rectangle. Rectangle's a predefined shape. And then leave this one alone for a second, because we have a different problem with this one. So here we are, bitmap, a bitmap. Bitmap, think of it like an image. Think of it like a bitmap, like a BMP. That's a bitmap image. It's an image. It's a bitmap. Google it. I'm calling my instance a bitmap. I am for image. Think of it like an image, a whatever, PJF, whatever, PNG, BMP. This is really more BMP compatible, actually. It's bitmap. So how do I get a bitmap? I'm going to use the bitmap factory. It's a predefined design template that's going to create the bitmap for me by going a .decode resource from the resource folder from r.drawable.circle. And you see I got this little line underneath where it says circle. And if I look at this advice, I'm going to go, well, this is totally wrong. I don't want to create the field circle in drawable. I just want to put I actually have to put the image in there. I don't want to change it to icon launcher. Instead, I'm looking at this going, well, r.drawable, isn't that r? Here it is here, resource. .drawable, and I got 1, 2, 3, 4, 5 different drawable directories. I got to put a file called circle something in there. The name of the file starts out with circle. It's got .png or something at the end of it. There's like 5 different formats that this supports. All of these guys here are for high definition. I think that's for LCD, MP, I don't know, XX high definition. Different levels of definitions because not all Android phones are made equal. So long story short, you could actually go up here, go File, New, and put in a directory. Here's a folder. You can create a folder and call the folder drawable, and then press Finish. And then I got another drawable. You can have as many drawables as you want. It truncates it. So you know this is drawable dash, 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 dash. So I could use drawable, or I could use one of the other drawables. It doesn't matter because it's going to start out with drawable, and it's going to go hierarchically through all of the other drawables, everything that starts with a drawable, and find what it needs until it finds circle. So I can tell I can attest this real easily by dragging circle into that folder. So you can create a drawable or you could not. Just select one of the other folders. It doesn't matter what folder you put it in. So I'm going to go and find my images. So I had you download the images folder as well. So it was called the APTTT images. In here I got a circle, I got a cross, and I got an empty. So I'm going to kill a couple of birds with one stone, drag them all in at the same time. So download the images zip file if you can get there. That one you're going to need actually. And then let's say get my screen so I can see both of them at the same time. So now I'm going to take circle, drag her, and put her into drawable. And copy the file instead of linking it because then it's all stored together. And lo and behold, the error message went away and circle turned into blue. So if you don't want to put, I put it into drawable, and if I click over here, I see circle is now inside a drawable. So I'm going to have a cross. So I'm going to put the cross in here too. And I got an empty. Okay, so the images are going to be at bhacker.com. And you see we have one that says called Tic-Tac-Toe images. It's right underneath Tic-Tac-Toe solution. If you got the solution, you have the images. You can draw them, you can drag them out of the solution and stick them into this file, into this folder if you want. So that's where you're getting the images from. You might just come up with your own images. Actually, one of my students gave me those images. It was from an iPhone application. But they look kind of cool because they're like kind of cursive looking. You might have your own images. Doesn't matter. So drag some images in there. You don't have to call them cross, circle, but remember what you called them. So we created a bitmap out of it. Now we're going to go g.drawBitmap. The draw bitmap draws it with the image. A parameter we're not going to use was going to be the resolution with new rectangle. So it's going to draw a rectangle. This actually comes from the built-in draw classes, and draw is imported up here. We have rectangle right here from graphics. I'm sorry, it's from graphics, not draw. So from graphics, we have rectangle imported. Rectangle is a rectangle. And the rectangle is going to draw it at a height starting position to a width starting position using the X and the Y coordinate system for the point that we're going to keep track of. So it's got X and Y in there. It's got W and H. We're going to pass it that information when we, because here's the parameters that are going into this draw. You'll see it when we create the main and we draw the X and we draw the O's. Because we're going to make an instance of an X, we're going to make an instance of a circle, and an instance of a cross, and an instance of empties, and we're going to populate the board with these instances of these objects that we created. Alright, so circle is done. And so I'm going to close circle here, and I'm going to open up cross. Oops, not that cross. I'm going to go back up here, open up cross. And I don't have to do anything with the constructor. Structure's good, but I need to add the code in here to draw the cross, which is going to be the same code as we just saw for the circle. So I come up here. Oh, we have a little method we have to add in. We have a couple more methods we have to add in there. I forgot. We have to add in the equals. So we can actually use the same code that we did, or I can cut it out of this one. I'll just cut it out of this one so I don't have to worry about typing it. This is the same code as we just put into the circle. So I'm going to paste this guy in here. Now I have a cross. And I'm going to have the same problem as before, but now the cross works because I dragged the images in. So now I'm going to have to import the bitmap. Import bitmap factory. If you want to, you can just cut and paste out of your circle and put it into your cross, or you could take it out of the PDF file if you want. Import paint, import rectangle. Now I have all my imports in there. And now I have the draw, and I have the default constructor, or not the default, the constructor, excuse me, for the cross. There's a couple more methods we need to put into the circle and the cross. We have a couple of them here. So this one is for the cross. I'm going to show you the cross, and we'll put it in cross, and we'll put it in the circle. So one of them is going to be an equals. We want to see if this object is equal to another object, because eventually we're going to see if there's something in there. So if we have an O and it's equal to a circle, and we're going to see if the circle is equal to another circle. If it is, we're going to use this one. Remember this instance of? So we're going to say if this object is an instance of cross, then return true, else return false. Because you know the word of the game, the name of the game here is to get X, X, and X, 3 X's in a row, or 3 O's in a row. So we have to see, is this one equal to this one? Is it equal to this one? We won! So we can check to see if we won. Plus also we can check to see who we are. Are you a circle? Or are you a this, or are you a that? So we can tell. So anyway, so we have to put this one in here equals. We also have this toString. ToString is going to be used for our little dialog box that's going to come up and say, hey, X1, Y1. So if we're an X, our toString is going to return X. If we're a circle, our toString is going to return an O. So I'm going to copy equals, and I'm going to copy toString. And I'm going to stick it in the one that I have open right now, which happens to be my cross. So underneath my draw, you could follow the order of the PDF if you want, and you would have done this in a slightly different order, actually. Oh, what do we got going on here? Let's do this one. Get rid of this override. There we go. Oh, what is that? Option, Command, Shift. What was the other one? F? Ah, F for format. Should remember that one. Alright, so now I have public boolean equals object. Well, if the object that we send it to it, we'll see the equals in a few minutes. If it's equal to cross, then return true, else return false. And then down here, we're going to have a string that's going to return X, because I'm a cross. But I'm a cross. So this is the code that I just put in here from the PowerPoint tutorial or PDF tutorial. You can cut and paste it yourself in. I'm going to save this guy. I'm going to do the same thing for the circle, but I'm going to change the word cross to circle. So let's see. This guy up here. Paste. Control Shift F to format it. Oops, how come it's not working? I'll get rid of this override here and get rid of this special space here. Control Shift F. There we go. So now I have to change cross to circle because I'm looking at a circle. And I'm going to change this X to a big O. There we go. For circle. Or you could put a 0 in there if you wanted to. It's just whatever's going to show up on the screen for whoever won, essentially. So now I have the two methods for the equal and for the toString. And you notice I got rid of this. If I come back over here, whoa, that's interesting. Wow. That's a different, I've never seen that happen on my computer before. I'm learning my new operating system. Anyway, so we got, well, in here it's not in here. Here it is here, the override. There's an equals method part of object to tell if one object is equal to another object. And we're overriding the equals method of object. Because remember, we're still from an object. And then down here, we're also overriding the toString. And the toString is returning instead of return, well, we're overriding it to return X or to return O. So we can tell from a string perspective, we can return who I am in terms of a big X or a big O. So I could print out X1, O1. Otherwise, I'll be printing out the object reference if I ran a toString on it, which is going to be a memory address. All right, well, we have one more. We have an empty space. So you might get an error if you don't have the images put in there. Add the images in there. Once you have the images in there, you should be pretty good. So go ahead and save them. Make sure you don't have any error messages. You don't. Now, we also have empty. Empty is when we haven't selected an X or an O yet. So we're going to add another class. We're going to call it empty. Class is not an abstract class, but it will be from cell again. Just going to look like an X and O, but it's going to be empty. So let's go ahead and add another one. But at this point, you're going to go, oh, this is a lot of practice adding classes. Yes, it is. New class, and this is going to be called empty, and we're going to go from cell. So at this point, you already have these steps memorized. You've done it 2 times already. This is the 3rd time around. Go ahead and click on finish. Go through the same drill we just went through. Empty. So I'm going to hover my mouse over here. I'm going to add the constructor empty. And then I'm going to add the unimplemented method here. And the unimplemented method is this draw method. I'm going to leave this alone. And I'm going to copy and paste what I just did a few minutes ago. I'm going to stick the empty code in there. If you don't want to copy and paste and do all this other stuff, just open up the solution at this point. So what do we got here? We got the bitmap factory, and it's going to take in an empty. We should have had one that said empty on it. So copy. In here, I'm going to stick in here. I'm going to make an image. And the image I'm going to make is going to be a bitmap. It's going to say empty. So go ahead and include the imports in here for bitmap, import bitmap. Import bitmap factory. Hello, there we go. Import paint. Import rectangle. Voila, my imports are done. Put my check to see if my object is equal to empty, and then return my empty or my blank string. That's going to happen at the end. So go ahead and copy and paste in these other 2 methods, or you could type them in. It's your choice. So I'm going to put them underneath. When I paste them in, here's a classic example of what happens when you paste it in. You see I have this weird character here that's causing an error. And if I hover my mouse over, it's going to say something really weird, like syntax error with a token, invalid character, delete this token. Because this token is actually kind of like a piece of dirt. It just came in from the cut and paste. Doesn't mean anything. So if I got rid of it. You can actually get rid of the overrides if you want as well. That's not a big deal. So I'm going to fix my formatting, which I just did. So now I have the equals, and you have to make sure that this is equal to whatever you called it. So if I put a capital E on empty, it has to be capital E on empty. So my object in instance of empty, then return true. If not, return false. And then my string here, it's empty. So I'm going to return a blank string. It's empty. So it's just it's not going to say X or O. It's just empty. This is so behind the scenes I can kind of see what this object is without having to deal with it like an object. So, okay, so I'm going to save empty. I believe I have all my board pieces ready to go. Those are all my choices. So I'm going to go back to the instructions here. Now I got to put the main game logic in. So isn't games going to be sort of like my driver? So my main activity is going to make an instance of game. Game's going to run. It's going to make some X's and some O's and put them on a board for me. So I'm going to add another class. It's going to be called game. This is not an abstract class. It will use cell abstract class as its implementation. And then it's going to use the following settings. So let's take a look here. Game. It's pretty much the same thing as we saw before. It says it's going to use cell. Let's see. No, it doesn't use cell. This is a typo. Let me say, well, it should not. But it will use cell. That's wrong. Game's not using cell. Why would game use cell? Game's going to make instances of the cells. But game's not cell. Game's actually going to extend view, because game is going to be our main driver class that's going to control our view. And our view is going to be having the 2D graphics on there that we're going to use. So if I come down here and I take a look at it, I see game extends view. So let's go ahead and create game. So I'm going to click on the project folder. I'm going to go File, New. I'm again creating just another class. This one's going to be called Game. And I could put View here, or I could just put Object in there. It doesn't really matter because I can always change it. So I'm going to go ahead and click on Finish. And then up here, I'm going to say, well, what's wrong here? Let's see. Create class view. Fix the project setup. Changing Android view to view. Now, I didn't import view, and it put the view in here for me. So I'm going to take the view out, actually, because I don't want view. I'm in Android. I want Android view. Because remember I said we're doing Java 2D? There's a graphics package called Java 2D. It works with Swing, it works with Android, it works with everything. It's core Java, actually. But we're in an Android project. So if I do this one, so I took out, it tried to think for me, so it imported view. I took out view. So now if I hover over and say import view, that's the view that I really wanted. And then what I'm going to see here, game. If I put my mouse over here, it's going to say add constructor game context. Sure, why not? So I add my constructor. Now I'm looking pretty good. Now I have my game. Because this extends view, the constructor from view takes a context. The context, think of it like a pointer to a view, to a location in your project that's going to be displaying this stuff. And I'm sending super the context. I'll explain model view controller as we get through later in the course, but this is where it's actually coming from. But let's take a look at here in terms of what we need to do. This one here has got a constructor. It might actually be a little bit different. Nope, it's the same, but we have added a few more items to the constructor. So I'm going to actually kind of start at the top of this file here. This is the implementation of game. Kind of go through the code, then cut and paste it, stick it in the project because it looks bigger on the screen here, actually. So what do we got? We have a two-dimensional array called cell, and our two-dimensional array is going to be 3 by 3. 3 X's with 3 O's or whatever. So 3 by 3 cell. You're not familiar with arrays, have a limited programming background, that's going to be a problem for you. But just take in consideration that it's a cell. It's an array of cells. Our X's, our circles and our crosses, they're all cells. We know this from the ISO relationship from an inheritance point of view. We just went over that instance of. And initially we're going to set the single square to null, which means it's not assigned anything yet. It's not a circle or a cross yet. It's just nothing. We're going to set our XY coordinate system for X is going to be 3, Y is going to be 3. Change it to 10 by 10, you'll have a 10 by 10 grid. Because we're going to use X and Y for the rows and the columns of our two-dimensional array. We're going to have a couple of support variables here. We have an integer L for length and integer A. We're going to have a a Boolean, what drawn is going to be equal to false. So we say you drew one, you didn't draw one. To keep track of the turns. Player winner is going to be equal to 3. Means if you selected 3 and the 3 all match, you won. And this is the paint, our canvas. This is actually Spanish. Is this Spanish or French? Canita, I don't know. I got this from an example actually. I thought it was funny. And I'm like, what is that? I googled it. It's like it's called a canvas, but it's in a different language. But anyway, don't quote me on that. I don't know. I have to go look it up again. I left it in there because it was actually kind of funny. So, it was used in another example, and I went, oh, that's really funny. And then I remembered, oh, it's paint. Anyway, we have a handler, event handler. When we click on it, the handler is going to figure out what we clicked on. Change an empty square, because we're going to populate the grid with empty squares. Handler is going to take the event of where you clicked, what coordinate system did you click on, in what box are you in, change the box to a cross or change it to a circle depending upon who you are, if you're player A or player B. It's the handler. Handler message is going to say, it's going to be a case switch, so which is why I gave you an example on case switch. Case switch is going to be message.what, well that's going to take in what the message was from the handler, And the handler you're going to see is going to be the coordinate system. Just take it with a grain of salt right now and you'll see it all come together. Case 0, it's invalidated. Break. Case 1, put a little toast message that says you won. Well, because you clicked on the last one, when this gets called, it'll get called after you've clicked on 3. It's going to add them all up, take a look, and then you're going to have 1, 0, 1, 2, or 3, depending upon which state the handler picked out. Is it a case in which O won, is it a case in which cross won, or is it nobody won? So here we can change the logic around, but either you won or the computer won. I think your X and the computer's O, actually, because you're playing against the computer. So we have a little toast message that comes up. It's kind of like, well, you'll see the toast if we haven't seen it yet. It's a little dialogue message that comes up and stays. This one's going to stay for a very short period of time. We can change the length along to see it. I have a toast example I'm going to show you in a couple weeks down the road. That actually is pretty cool. Otherwise, the computer won, or you lost. Computer won, or nobody won. You won, computer wins, or we're done. It's a draw. Nobody won. And then super, handle the message. Send it up to super to garbage collect the message text and to do whatever it is we need to do with it. So we have a method here that says integer set the game size. So we return X, and we have one here that says going to be our constructor. We actually made the constructor part already. We have the canvas for the paint is going to be equal to a new paint, and the new paint we're going to set the RGB colors, we're going to set the aliases, we're going to set the style and the stroke. We're just going to set stuff about the canvas. Don't worry about those settings at this point. We're going to get the width and we're going to get the height of the canvas that we started out with, because we don't know how big our screen's going to be. So some of you are going to have emulators that are this big, and some of them are going to be this big, and tablets and phones, they're all different sizes. So we're going to get the initial canvas of what we have on the window. Divide that out into 6 squares. So we're going to set the X's and the Y's, and we're going to go through a little loop, a loop inside of a loop, to set the coordinate system for our 2-dimensional array. When you have a 2-dimensional array, you usually have a loop inside of a root for rows and columns. So you can get the coordinate system to set the single squares. It's going to be equal to a new empty. So remember, we have empty, we have cross, and we have circle. We're going to make a new empty. This calls the constructor, giving it the height, the width, the X, and the Y. So we have a starting position that we're going to figure out, and we have the height and the width from that position. And also that constructor is going to call the draw. It's going to put the empty.png. This one's going to put empty in there. We have one that's going to put circle.png and stuff like that in there. So yeah, further down the road. And then we have an implemented on draw that's going to draw out the canvas for us to give us our coordinates, which is kind of a long method actually. And then we have an on touch event. So we have the handler that's going to handle what we're going to call with the touch event that happens. We attach the touch events to the squares that we're going to put in there. So we draw the image, then we return super.onTouchEvent from an on-touch event that we're going to put on the images. So when we touch the images, we click the images, we tap the images, it's going to put it, if it's our turn, it'll put a new instance of the circle or the cross or whatever is we're having there. So get the piece. So we're in the whoever player we are, we only have 2 players, 0 and 1. So we're going to say, is it 0? Is it 1? 0, 1. Return X, return O, depending upon who we are and what piece we're looking at. Draw the image. Takes a cell. We're all cells. Every one of us is a cell in this example. And then if what drawn is, depending upon what number it is, if it's true or false, if we haven't drawn it yet, because it's only going to draw it once, then the cell is going to be equal to a new cross, and then, or the cell is going to be equal to a new circle. We're only going to draw crosses and circles. So when we run this new cross, we're going to again send it these 6 items. Same thing as we did with the empty. We made new empties and we put 6 new empties out there. Well, now we're going to put new crosses or new circles where the empties used to be, depending upon where we clicked. So, validate game. basically see if there's a winner. So if if you're true, we still have turns left. And it's your turn and you put the item in there and it all matched up, then you won. And we're going to send the handler 1. Otherwise, the computer won, and that's 2. So we're keeping track of who you are, 1 or 2, depending upon if you're player A or player B. And then else if it's full, means this should say tie instead of lose. It's a tie. You lost in a tie. It's really a tie because all the board is filled and there's nothing in the row. Nobody won, but the board is filled, which means you can't put any more X's or Y's in there, or O's, excuse me. And then resize the game X, validate the game, yada yada. What you're gonna have to do, and let's just do it right now, cut and paste, put the code in, try the game out, and then study the code, because then you'll see what which one of the pieces is doing. So let me put the game in. So this is going to be tricky here. Let's see. I'm actually going to take the entire game code here from public class game extends view. I'm going to copy it in and remove what's in there already. We still have to set the onCreate method for the main activity. This is just the game. But the way you're going to understand the game is to actually go through it at a lot slower pace, play around with the Java code. So let's see. Copy. Let's see if my game works. So I'm just going to pull out the whole game method, actually the whole game class code. I'm just going to paste this in here. And then, let's see. Ah, good, good, good. Let's go back up here. I know I have a handler on the bottom. So I'm going to hover over here, and I need to put paint in, so I'm going to import paint in here. And I'm going to import handler. And I noticed what I did is I actually went up to the top of the code to start the imports instead of working at the bottom of the code. Because if I fixed it up here, my handlers down here are now gone. Because that code is going to go away. So I think I have to put message in here too. So I'm going to put message in here. Import message. Import toast. Toast is a no-brainer. Put toast in there. So now I'm looking pretty good. I got my two-dimensional array. I'm going to come down here and I got style. Okay, let's import style. And then now what I got here, canvas, import canvas. Motion event, import motion event. This is not using buttons, so there's no on-click listener for the buttons, and no event handler. It's actually using a higher up the hierarchy. It's using a different event level in the event listener classes. So anyway, it looks like it appears to have worked. If you have a problem with it, go to the solution and maybe pull it out of the solution file, or just go to the solution. So that's the game. And as I was mentioning before, because I know that you guys, half of you probably don't know Java, it's probably senseless for me to go through it in a lot of detail, because it's not going to make any sense until you actually kind of look at it and understand what the code is actually doing. But we're just making instances of across instances of an empty, instances of an O, and providing the logic for testing to see who won, if anyone has won, and then what, if a user does click, pick up the click event, figure out, well, what coordinate system did it click in. So now that we have the game logic in there, we shouldn't have any errors. So now we're going to change the source code to the main activity class. So we're going to change the main activity class, and this is the easy part actually. We're going to create an instance of game, and we're going to call it game1. So we have private game, game1 is going to be the variable that we're going to use. So I'm going to go back up to main activity, and I'm going to make a reference, because I'm going to make an object called game, and I'm going to put it in here and paste this in here. So now I have private game, game1. It's going to be the game, instance of the game. Because what we're going to do is make an instance of the game and then run the game. And then the game itself is the object that creates the empties, the cross and the circle objects that are all cells. So. All right, so now on the onCreate method, game 1 is going to be equal to a new game this, and then we're going to set the context view to game 1. So I'm going to copy these 2 lines of code in here, stick them underneath the super create instance here. Paste. And then you're going to see, well, what's this context view here? Because we did this entire app in Java. This is core Java, by the way. We didn't use the Android interface for it. We did this in 2D Java. We don't actually need to set the context view to activity main, because we're going to set it to game 1. Game 1 is going to put up a canvas for us, and the canvas is going to be sized the same size of our window, and or our view, actually. And it's going to contain all those images that we're going to tell it to contain. So actually I can comment this line out or just take it out completely. I don't need it because I'm setting the context view to game 1. It's doing all the graphic stuff for us. If you create an OpenGL app, this is what you're doing. You're not going to use the XML stuff. You're going to use the OpenGL canvas that you're going to create and the OpenGL object that's going to be just like game as in this particular example. So we made an instance of game. We said game 1 is going to be equal to new game this. We're going to be this game. So new game this. And then set the context view to game 1, which is game 1, which is equal to new game this. So now you're not going to receive any error messages since all of this code and this stuff has already been implemented in the previous step. So now it's time to add the images. We already added the images to the project, so I'm going to make sure I haven't missed anything here. If I add the images, I'm done adding the images, so I should be done. So let's take a look here. So make sure that your onCreate looks like this, and you have the instance object created. You don't actually have to stick this up here. You could stick it down here. You could say game 1 is equal to new game this if you wanted to. Set the context view to game. Save it. No errors. Nothing. So let's go ahead and run it. So I'm going to right mouse click on Tic-Tac-Toe, run it like an Android app. Select the emulator here. Say OK. And my emulator is right here. Look at that. Looks like a tic-tac-toe game. And it's filling up the size of my screen, actually, because we set it to the view. So I'm going to, oops, let me get my mouse integrated correctly. Yep, my mouse is integrated correctly. I'm going to move this little guy. So now this little guy's in the way. So now I'm going to click on here. Oh, I'm O. Okay, so the computer must be X. So X. Ooh. Well, okay, the logic is funny. The logic is screwy. So originally the design was supposed to be, it's supposed to come up, but I took out, it's too, the original code, believe it or not, was too advanced because it had a timer in there. So as soon as you click something, 2 seconds later something else got clicked and it was the X, and then you did the O and it did the X. So really I'm the computer and I'm also the user. So if I go O, X, now O's going to win. So here's my toast. It says you win. Is it O1? And then the board's going to reset. So, but now I'm X. So the logic is kind of screwy because remember the first time I clicked it, it was O, but I didn't reset the whose turn it is. So we have a 1 and then we have a 2 for the X's and the O's, and it's still on my turn. So if I win it again, well, let's have the X's win this time. Your computer won. So now when I click it on, it's going to be O again, because it's going to be the exact opposite of the last person who played. So, if your screen is smaller, your board's going to look smaller, obviously. So I think I'm going to have a you lose here. Oh, you win. How did I win? I'm trying to tie it right now. O, X, O, X, O, X. Lose. So that one should say tie. Yeah, that's the one that actually tied. Not working?
The third one is not getting displayed.
Which is the third one?
If
You mean the third button?
If I win the third one, what can display?
If you win,
It just gives the message, the alert.
Hold on.
If it wins on the third click, the third image won't get displayed.
if it wins on the third, it's not going to be displayed.
The toast is
Oh, on the third?
The third
Like this one here?
Yeah,
Yeah.
if you win this one,
How can you win this one though?
put that one
next
down.
click. In the third click, if we are
Computer
successful,
wins.
Yeah,
the
like
third
that.
one won't get displayed. It's not getting displayed.
How can you win on 3 clicks though? You can't win on 3 clicks. There's something wrong with your code. 1 click, 2 click, 3 click. They can't all be O's. And they can't all be X's. 1 click, 2 click, 3 click.
My third click of my not the total click. She's asking third chance.
No,
Third
no, see,
chance of
what
mine.
my question is, when a person is
Oh,
winning,
play another time?
No. So when the person wins,
Yeah.
with the last click, if there are 2 O's and if the computer is playing or I am playing, if I put the last O there, the O is not getting displayed, it just pops up with the toast, like you win or the computer wins, without showing that last O.
Oh, it's probably buggy. The code itself is really buggy. The demonstration was to show you the cell and the circle. Alright, so if you want to play around with it, you can go back up to game and change your parameters here. I can double the board size, go 6 by 6 if you want to. If you go and you run it again, it'll come up with, you save it, and you run it again, you get Tic-Tac-Toe on steroids. You get 6 by 6, which is kind of weird. You can go through, and actually the code itself is quite primitive. It probably could be improved upon. In fact, you can probably make a lot of improvements with it. It's meant to be a learning example, not necessarily a state-of-the-art tic-tac-toe game. But the learning example of it was from the Java perspective. So if the Java code is bothering you, then go ahead and open up game and just dissect it and start playing around with it. And then you can start and maybe even change the logic of the game a little bit. And you can possibly learn from it from a coding perspective. If source code writing is your weakness, then it gives you an opportunity to kind of play around with it. All right, so you should have a working tic-tac-toe game. If you don't, you can go out to behacker.com and download the working game. There's another game in here I want to show you that's another tic-tac-toe game. That's in the Android directory under tutorials. This one is called Tic-Tac-Toe Solution 2. So I'm downloading Tic-Tac-Toe Solution 2 to show you yet another way. And so this one, the solution for this one is the regular solution we just saw. The images, you can put your own images in there. So I'm going to kind of close this project here, import to. Actually, I'll just leave my steroids. Actually, the steroids actually work, but they don't do it. They only do 3. So the 3 has to be like 1. There, now I won. Because of the logic. So anyway, so I downloaded part 2, or Tic-Tac-Toe 2, and it's called Tic-Tac-Toe. So be careful, you'll have to actually remove it from your workspace directory or zip what's in your workspace directory if you load this one in. Otherwise, you're going to lose your first one. I don't care about my first one, so I'm going to go ahead and just delete it. So if I go into my Eclipse folder here and I delete this guy, Tic-Tac-Toe is gone. I'm going to delete it from the disk as well. It's just I have the project anyway, so. So now I'm going to import the number 2, which is sitting on my desktop, to show you that one real quick here. So I go File, Import, and I have to actually select the existing Android code into Workspace instead of it being in the Java directory. So I'm down here under the Android, because this is an Android project, by the way. You're going to do the same thing if you're importing the first one as well. And so I'm going to go ahead and click on my desktop and then click on Tic-Tac-Toe. And then I'm going to import the Tic-Tac-Toe game from here. And it's going to tell me that there's an I/O exception because no such file or directory. Okay. I don't think that's going to be a problem, really. All right, so now what you're looking at is another tic-tac-toe game. Let me just make sure I'm running first. Here's the other tic-tac-toe game. The other tic-tac-toe game looks like this. So it's on the canvas. And on the canvas, you're looking at not a core Java 2D application. Instead, you're looking at an Android tic-tac-toe game. The other one we just did was completely Java. There was nothing Android about it. It worked in an Android app, but it was 100% Java. If you're writing OpenGL, Java 2D, Java 3D, any of the third-party packages that do graphics, a lot of the game programming works that way. That's how you're programming it. It's all in Java. If you're going to do it the Android way, with minimal Java skills, not worried about the graphic capabilities, you're doing it this way. You see I have a regular old canvas, and on the canvas I've got some buttons. And the buttons, I click on them, and I'm using a button click event. And I'm going to have the same behavior as before, except for X1. The dialog looks a little bit different. Not using a toast, I'm actually using a dialog for it. And you got a regular old game that goes on. So the code for this, you'll see, is going to be a lot easier. I didn't even give you the project for it or the tutorial for it, because it's extremely simple. What you got, if you import I got a little message for some strange reason. I wasn't quite sure what that message was about. But if you import, seems to be working, import the project, you see you've got main activity.java. And then I go into the resource folder. Remember, we didn't do anything with the main XML file. All we did was drag some images and stick it in there. So if I come in here and look at the layout, and I click on the activity main.xml, here's my layout. I look at it and I got a text view that says hello world on it. And I look at the XML stuff and I say, well, that's really funny. Where's my board? I don't have a board. So there's a group of people, and you can do this. Actually, I have a third version of this. You can actually drag and drop, and you can stick the buttons on the board. And then we can change the icons on the buttons that are on the board. But if you know you're going to put buttons and you're going to put a board out there, you're going to spend hours trying to line them up correctly and try to get it to look good. You can do it that way. That's the baby step. I'm not going to say that's baby step, but the board doesn't look that good. The board's just the board. The board is, this is the interface you're looking at. So you don't want to take this approach. You go to this approach. Let's take a look at the board. So this code, again, is not the most effective, but it's made for simplification. If you didn't understand the first tic-tac-toe game, you will understand this one. No brainer, no Java. All right, so what do we got? We got main activity, extends activity, same as before. We're going to keep track of what was selected, the count, and whether we got a winner. So we still got our onCreate. Our onCreate is going to use our activity main. That's that main screen we just looked at that said hello world on it. And now we got this thing called a button. So we got a button on click. It's an on-click listener method that we can run. And this is Android, by the way. And we're doing it on the view we didn't create, the view we got from the setting to context view to activity_main. So we have our on-click, our button on-click method. And so we're going to get the ID of the button that we clicked. And if the ID is equal to button 1, button 2, button 3, button 4, button 5, button 6, buttons, we got 9 buttons on that screen. Depending upon what button it is, like I say, this is not the most efficient, but it's the easiest to understand. We're going to say that the selected is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. What button did we select? Well, we're going to set an integer value for that. And then we're going to do a method called calculate. Calculate's going to see if we have a winner. And it's going to essentially do all the work for us. So we click on some buttons, and on the button on click, which is going to happen automatically when we click on the button, then it's going to set the what button do we press. On calculate, it's going to put our images on the buttons. So counter plus plus, we're going to increment the counter, so we have time is 0. First button gets clicked, that's 1. Second button, that's 2, 3, all the way up to 9. Because if 9 buttons got clicked and nobody won, we tied. So counter 0. Clicked on a button, now counter's 1. So we have button image number 1. Well, let's go get it from the ID. And what do we have on the ID? We're going to find ID image button 1, image button 2, image button 3, image button 4, all the way up to image button 9. And then we're going to say, we're going to calculate whose turn it is by odds and evens. 1, 3, 5, 7, and 9 is one person's turn. 2, 4, 6, and 8 is the other person's turn. The logic could be improved upon. And then we're going to do a case switch here. What are we going to switch? What was selected? Was it button 1 or button 9? Button 1 through 9. And if it was button 1, then we're going to set the button 1. We're going to set the image to drawable X. And then we're going to set the text context description to X. And then we're going to disable the button so we can't so we can't click it again. And then we're going to go through it. Else, if the turn is 2, 4, 6, it's the other guy's turn. Then we're going to set it to a 0. Lots of redundancy, no Java programming required. Very simple. And then check for a winner after each turn. So we're going to check the horizontal wins, the vertical wins, and the diagonal wins. And if this one here is equal to this one here, and that one here is equal to this one here, very low tech, very low brainer. And then here's our little dialog. So we're going to set up an alert dialog. Dialog alert. It's going to be equal to new alert.builder this. It's the way of creating a dialog box. There's actually a couple different ways of doing it. This is probably the simplest way of doing it. And on the dialog box, then we're going to put the text that set the title to X1 if it's X's turn. If it's Y's turn, set it to O1. And then set the position set positive button to OK, which means we're going to put a little OK to close the button. Close the dialog, excuse me. And then show the dialog. Else there's a tie game. And so here's how we're getting the buttons on the board. So we're going to reset the board. Well, it could have been just board. Create board, reset board. Called a reset board because it calls at the end as well. Calls at the beginning, calls at the end. So to reset the board, we set the image buttons to image button. Image button 1 is an image button. Find the image button by image. Image button 1, image button 2. So if we look at drawable, we have our blank, we have our 0, we have our X. Same ones as we used before. So button number 1, set the image button to blank, button 1, blank, button 1, 2, button 3, button 4, button 5. Set them all to blank so that when we click on them, they'll be changed to O or to 1, depending upon which one we clicked on. So, and then set enable to true. So we're enabling the buttons, disabling the buttons. We're creating the buttons, putting the buttons out. So why didn't I see my buttons on the, I should have seen my buttons on the layout. Where are my buttons? Yeah, relative layout. Huh, interesting. It's in the resource. Hold on a second. Just take a quick peek here. Huh. Well, I know I'm putting the buttons out there. Because I just didn't build this from scratch right now. I got to refresh my memory on how the buttons got out. Let's take a look at the onCreate again. Activity main. Activity main. Huh. Interesting. Let's take a look at the onClick one more time. Calculate. Well, in any case, it's not the most efficient design, not demonstrating too much Java skill. You'll see more of this than you will see the first tic-tac-toe that we put together. Because the first tic-tac-toe we put together from a Java perspective, a lot more coding with that. So what we're going to do then, following next week, is build more projects, but start with this and then work to the Java extreme a little bit more with different types of projects. So also as we go through, I'm pretty much wrapping it up for today, but also as we go through, we'll see some people might have some suggestions in terms of what kinds of projects you want to see. As soon as we start going through more projects, which is going to start next week actually. So the idea is every week we'll go through like 2 or 3, try to get through at least 2 projects, depending upon how big the projects are. Sometimes we'll be building the screen itself. This, we didn't build anything yet, but sometimes we'll be building the interface, then adding the components to the interface, and then putting the listeners on the components. Sometimes we'll be checking out different layouts, different features, different components to see how they work, and we're going to build different themes. So if there's anything in particular that anybody wants to see, I have like a ton of examples, so I pick and choose from different examples depending upon the level of interest in what people want to see. If there's anything in particular that you want to see, send me an email message or tell me before or after class so I remember. Say, hey, I want to see how to do a solitaire. I actually have a card game. I have 21 actually. It's just the same as Tic-Tac-Toe. You're just putting out squares, and you click on the square, and it changes from this image to that image. But you use random, and you can pick a random. We have a puzzle. I've got a couple of other hangman games, something else. I can't remember what it is, but miscellaneous games. There's also a couple of apps that we'll build that will work with the contacts, with SMS messaging. In fact, we'll probably do SMS messaging next week, actually, because that was a really cool project. Features of the phone, broadcast receivers, services, notifications, all sorts of different components, putting them together, and then nesting interfaces, and then we'll get to the point where we can add multiple types of activities to the same project, switch between the activities so that one activity calls the other, kind of like what we did with Hello World. And then add a service to it and kind of mix the components up a little bit. So what we're going to be doing is kind of experimenting with a lot of different design patterns associated with Android as well. So your homework, see if you can get Tic-Tac-Toe to work. Start reading through if you've got any of the books that you've downloaded. And come up with any ideas that you might have for anything, any suggestions for any apps that you might want to build in the future. So I can always add them to the list. Or actually, most likely I have it. I probably have something similar to it already. And then we're done for this week, unless we have questions. Nope. Okay, we're all done. Thank you. Now I could talk. Oh, you have a question?
When you
Oh, okay, come over.